Hi, everyone. Thank you so much for coming along today. My name is Jonathan Giles, and I'm going to be talking to you today about Java API design best practices. I'm a principal Java architect at Microsoft. Basically means my team is responsible for building out the Azure SDKs. We want to connect to all of the Azure services and provide a really good developer experience for all Java developers. We want it to be an idiomatic experience so that it feels like it's been designed by Java developers for Java developers. If you have anything to say, feel free to reach out to me at jonathan.giles@microsoft.com or at Jonathan Giles. It's important to note that this presentation is about Java API design in terms of client libraries as opposed to RESTful web services. We're not going to be talking about HTTP gets and puts and posts. That's someone else's job. My job's about the API design where we build client libraries with public classes, interfaces, and that kind of thing. Now, this is normally a talk I give over a couple of hours. It's been condensed into 25 minutes. I'll try my best to cover as much as I can in that time. We'll go fast, and hopefully there is some use for you in this. So just very, very briefly on who I am. I've been an API designer for a very long time now. I worked at Sun Microsystems and Oracle on the JDK. I worked in the JavaFX team where we built the UI controls that were part of JavaFX. So I did a lot of API design for the tables and the lists and those kind of UI controls. And then I would obviously build the implementation for those types as well. Like I said, nowadays I'm the architect for the Azure SDKs here at Microsoft. And more generally, my passion is about developer experience. I want to make sure that developers have a really good experience when they're using client libraries. So there's so much more to it than just API. There's documentation and samples and GitHub repositories, and basically anything that's going to create a friction that prevents a developer from using our libraries is something that I care about. And just very, very briefly, I'm fortunate enough to have been recognized as a Java champion, a Duke's Choice Award winner for my open source contributions, and a Java 1 Rockstar. If you haven't read this book, I highly recommend everyone to read it. If you haven't read the third edition of this book, I recommend that you get the third edition and read that, because a lot of what I'm saying today is common knowledge. It's kind of just kind of obvious. It's about developing a gut feel. And this book codifies all those gut feelings into a really good set of tips for all Java developers. So grab the third edition and make sure you just read it front to back and keep it on your desk. My one's right next to me on my desk all the time. So what is API design? Like I said at the beginning, we're talking about API design in the sense of Java classes, types, enumerations, that kind of thing. So the metaphor I like to use sometimes is that it's like a sandpit. And we've turned up to the sandpit and we have a completely blank slate, just like when we turn up to our IDE at the start of the day and there's an empty screen. And in the sandpit, it's our job as the first person arriving to create the interactions for the other children to play with, or in the case of API, the other developers to use. And we're going to create the sandcastles and the rivers and the ponds and the bridges and everything. And how it's implemented under the hood is our concern. It's the interactions that the other people get to encounter that is the API that we're caring about. And so to kind of put it in a slightly more concrete way, API is what a developer uses to achieve some task. It abstracts over an implementation, allowing them to work at a higher level of abstraction. And it's really important to note that API design isn't some level on a career ladder that you get to after, junior, senior API designer. I like to say everyone's an API designer, just by the fact that we are all writing public API that has public interactions that other people may use. It doesn't matter if the API has been designed just for your own use, for your team's use, for an open source project, or for a huge open source project like Azure SDK or the JDK. We're all API designers, and we should take some degree of care in our API design so that users get a really good experience out of it. So I'm going to spend the rest of this talk speaking about is just a few API characteristics. I'm going to talk about the importance of it being understandable, well-documented, consistent, fit for purpose, restrained. I don't have time to talk about evolvable. I've cut that one out already. So what does it mean for an API to be understandable? I like to kind of talk about the front door. Imagine the front door of your house. Imagine someone turning up to your house and there not being a front door. How do they get into your house? It's the same with API, right? We want people to be able to walk up to our API and understand where the front door is. What's the first class that they should interact with? And we want to think about it in the sense that we don't want developers to have to go to Google, to go to Stack Overflow, or Javadoc or anywhere else. We would love it if they would find the front door just through naming conventions. And so that's something that we do really heavily on the Azure SDK for Java team, is that we've got naming conventions that encourage people to try these types as potential front doors. Everything that interacts with an Azure service is called a client. To create a client, you have Client Builder. So we've got these naming conventions that encourage users to get started and find the front door. And it's our hope that by doing that, they're not going to give up and go to a library. And so consistency is really, really critical. We don't want to surprise our users. And we're going to talk about a whole bunch of different ways that we can have consistency in our API. And the reason why we want consistency is because developers aren't consuming all of our APIs at once. They're going to consume a little bit to start with, and then more and more as their needs arise. And in the Azure SDK team, we've got an even bigger argument for consistency because we don't have one library for all of Azure. We've got a library for each service of Azure. So we have a Key Vault library, a storage library, a Cosmos library, an Event Hubs library. And what we want is for a developer who's familiar with the library for one of these services to be able to pick up another library for another service and it feel like it's been designed by the same people with the same design patterns, the same philosophies behind it. So one thing my team does is that we have a really long guidelines document that specifies all the rules that we have when building libraries to be consistent. And I'm going to list just a few of the consistency rules that you should consider when you're building your own client libraries over the next few slides. So there's nothing worse than when you're a consumer of a library having that return different types. Imagine if you had a library return list, collection, iterable, stream, whenever you have some kind of collection to return. You'd have to write code to handle each of these types differently. And that's going to result in users being disappointed in you for having them write a whole bunch of code that they wouldn't have to do if you were just consistent in your return types. Choose the right type for the right case, but if possible, be consistent as much as possible. Keep the minimal set of return types is basically what I'm saying. And similarly, if you have a API that's, if you've got API that returns string, for example, and you document in all cases it's going to return non-null, so it's going to return like an empty string instead. And in some cases, you return null by accident, you're going to turn your user off. You're going to make them never trust you again. They're always going to be defensive and start null checking in all cases. So it's really important when we document we won't return nulls and for a particular type that we are very consistent in doing that. And just speaking briefly about null pointer exceptions and returning something other than a null, there's a few options we have in Java to avoid this situation. For example, instead of returning a null string, we could return an empty string. The collections types, list, set, map, iterator, all have API in the collections class to return an empty list, an empty map, an empty set. We should definitely use those rather than just returning a null, because the user's just going to get an empty collection that they'll iterate over. There's nothing in it, so it's basically a great big no-op. Stream has stream.empty. Arrays, we can just return an empty zero-length array. And JDK 8 introduced the concept of an optional. An optional is a really good choice that you might use for returning things that may or may not be null that you want the user to be defensive about without necessarily running it into null exceptions. So you wouldn't believe how much effort goes into method naming and type naming inside the Azure SDK team here at Microsoft, as well as when I was at Sun and Oracle previously. We would really agonize over the names of each individual class, method, interface, you name it. We would sit around our meetings and just make sure that we've got the right name for the right situation. And there's a lot of effort that goes into establishing a vocabulary that enables us to be consistent across all of our libraries. And it's not just for the types, it's for everything. Method names, arguments, constants. We should have naming conventions for everything. And there's all kinds of choices we could make. We could be Java being or not Java being. We could have fluent APIs or not fluent. We could have builders or not builders. And there's no particularly right or wrong answer. The main thing is to be consistent. Often you look at libraries today and they're kind of a mishmash of a lot of different naming and design patterns. And it just leads to a great deal of confusion for the end user. And so names like .of or .value of to XYZ, .from, all of them are totally fine as long as they are used consistently and the user can understand and they can intuit why the name is the way it is. Because when they come to another class and they're looking for a similar piece of functionality, they're going to try the same patterns that they've used previously. So carrying on, one more slide about consistency is argument order. It's so frustrating when you're a user of an API and you have multiple method overloads where the argument order switches around between the overloads. This is not only frustrating for the user because they have to start finding the right place to put the right arguments. It can actually be a really big error situation because sometimes the types might be the same, but they'll be going into the wrong parameter position, and the code will continue to compile, but it won't operate as expected. And one thing that we've started doing a lot in the Azure SDK team is introducing what we call option types, but I've called them argument objects here. The problem that exists in especially web services is that web services tends to get more functionality as time goes on. And the way the functionality is exposed through client API is to add more and more arguments into a method or have many more overloads. You start getting this telescoping of overloads as more and more added. And what we don't want to have is a cognitive burden on the user where they're presented with 3 or 4 or 5 or 6 or 7, a huge number of method calls. So instead what we do is we have these option types or argument objects which take all of the parameters that are known about today that could go into that web service call, and then we've got a class specifically for those parameters. As the web service or whatever causes us to have more arguments, we add them into that argument object rather than into the method call itself. This allows us to grow the argument object over time without having this cognitive burden on the end user to see so many more APIs coming up in our clients' top-level APIs. So just very, very briefly, fit for purpose, I've only just got this one slide because it's pretty obvious. When you build an API, we have to know who we're building it for and who our user is. So I like to talk about the new datetime API that came in Java 8. We could have built an API, new datetime, that was extremely complex, that was perfect for space, state, time, kinds of esoteric use cases. But that's not really the datetime API that Java developers like you and I want to have. We want a much simpler API. So Java was right in creating a simpler API rather than a complex API. So we have to know who our users are, and we have to design our APIs to hit the right level of user. So perhaps my favorite topic on API design is just the importance of being restrained. And I've got this tweet that I'll just read out. It's from 2018 by Scott Bollinger, who says, "At this point in my career, I understand that a feature that only takes a few hours to build can create hundreds of hours of support and maintenance in the future. Just because it's easy to build does not mean you should add it to your product." So I'm going to spend a few slides talking about this because it's really important that we don't just add API for the sake of adding API. That's something that we do when we first start building APIs, thinking that we're helping users, but really we could be doing the opposite. The problem is that when we add APIs, there's we have 2 problems. We introduce cognitive overload to the user. Like I've said before, every piece of API is something that the user sees when their IDE pops up, their IntelliSense pop up, that shows all of the available API. That's problem number 1. Problem number 2 is that we have to continue to maintain it, document it, test it, and so on. The way I kind of think of it is we have to pay rent. All of these APIs have to pay their rent for the amount of land that they take up inside our API. So every API designer should ask themselves, do I really need this API? Is this something that's actually critical for my user, or offering so much convenience that it's going to pay for itself? It's going to pay the rent that it has to pay. Because it's so easy to say, and I'm guilty of this too, it's so easy to say, I'm going to save the user writing 4 lines of code by giving them this one piece of API. And that's sometimes the most fertile ground for regrets. Later on, once you've shipped your API and you can no longer take that API away, these are the places that you might just regret because maybe it's not been as well considered as the main API. And so sometimes you regret adding these things once it's too late. And so you always have to ask yourself, does adding this increase the burden on me as the API designer? Having said all of this, though, it's important to note, I'm not saying don't have Convenience API. Convenience API is actually really, really good when it's well justified. So 2 examples I've just picked out. List.of in the JDK 9 or so is a really great way to create a list. you just throw in a var_args and a list is returned. List.add is an instance method that lets you add an element into a list without specifying the index where it should go, which is obviously a really good use case because most people don't care about where it goes in the list. They just want it in the list. And so these kind of convenience APIs save the developer a huge amount of pain, and it also saves them from potentially introducing errors. We could have an index out of bounds exception, for example, with the list.add if we passed in a bad index. So what I'm saying is API design isn't a science, it's an art, and there's a lot of gut feeling that we have to work through to understand what's the right level of convenience that we should add to our APIs. Going further about restraint, we have a few keywords in Java that are really useful. The first one is final. I tell everyone that I work with, we should make all of our types final until such time that we are convinced that they should be made non-final. Final is the keyword that prevents subclassing of a type. It enables us to retain control until we are ready to say that subclasses are allowed. Coming up soon in a future release of Java is the sealed keyword, which is kind of like final, and it prevents subclassing. Sealed is only different in the fact that you specify which types are allowed to subclass it. So that's an interesting API designer's tool in the future. It goes without saying, private modifiers should be used extensively. We don't want everything to be public, and we only increase the visibility of methods if they need to be made public. And I've always been very wary of the protected keyword. Protected is I tend to think of it as a virus. If you don't design your class with protected in mind, what tends to happen is the user will subclass your type. They will override the protected method, and they'll say, actually, I really need this particular functionality to be protected too, and then this particular piece of functionality to be protected too, until your API is kind of not really what you wanted it to be in the first place. You've made these changes to your API because it wasn't designed up front to be subclassable. So it's really important, if you do think that you want to be subclassable, to make sure that you write subclasses that actually test that out to make sure the functionality that you think you're enabling is actually enabled. So another area that I'm really big on is the split between implementation packages and public API. Implementation classes are classes that are used to implement our API. We don't want users to use it. We just expect that to be in our library that the users can't get to. Prior to Java 9, there was no way to limit access to particular packages. Obviously, with Java 9 and later, there are now modules, so we have the ability to not export particular packages. It's really important, though, to have tooling that checks against your leaking of implementation classes through your public API. So in the Azure SDK team, we've got check style rules that validate that any return type or any argument into public API is not something that exists inside an implementation package. We also have our Javadoc tooling not generate the Javadoc for any of the implementation code. And we've got two choices on how we do this. We can either have an implementation package, which is really nice with the JDK9 modules, or even better than that, we could just have package private classes inside our public API. These package private classes can't be accessed by any class outside of that package. So either way, we're doing the best we can with the constraints that Java gives us to separate our API from implementation. The same goes with external dependencies. Just like implementation leaks are bad, we don't want to have external dependency leaks if we can help it. If we have an external dependency on an Apache library or any other library, we have to think really hard about whether we expose that through our public APIs, because once we do that, that becomes part of our public API surface area. And we have to be careful that these external dependencies have the same breaking change policies, support policies that we have, or else the burden falls on us to make sure that we can support these external libraries as well. And one option that we have is to wrap these external dependencies in the type that we've created so that we can change the dependency under the hood and still maintain the same functionality to the user. So a lot of this boils down to eating your own dog food, as the saying goes. We've got to have developer empathy. We've got to see the problem domain from the user's eyes and make sure that we're not solving problems that we like to solve as computer scientists, but rather solve the problems that our users have in wanting to use our APIs. It's very easy to get carried away when we're building an API to do cool things rather than the right thing. So we have to write sample code, discuss it with real users. At Microsoft, we do user experience studies every week with our Azure SDKs, where we're asking real world users, what do you think of these APIs? Please perform these tasks for us and tell us, was it good or bad for you? We have UX labs doing this just day in, day out. And when we write our own sample code and when we ask our users to write sample code, we want to make sure that we're checking for unclear intentions, duplicate or redundant code, or whether the abstraction that we've done is at the right level. I'm just going to briefly talk about documentation. I'm a huge fan of JavaDoc. I want that to be the first port of call for all users. I want them to have a really great JavaDoc experience. I want people who are writing JavaDoc to use all the annotations that JavaDoc supports, the Cs, the synths, the link, all of those make for a richer JavaDoc experience. And I love seeing JavaDoc that has code snippets in it. I would love if all users of my library would go to JavaDoc before they went anywhere else. And this is some JavaDoc I wrote a very long time ago now. This is what I like to see, just a page full of really good explanation text. It's also a really good way to review API. So getting into the habit of generating the HTML output and reviewing it is just a really good thing to do, because when we're looking at JavaDoc, we're seeing the API through a different lens. We're not looking in our IDE anymore, interspersed with a whole bunch of implementation code. We're just seeing the API. So we can look for things that don't feel right. We can look for poorly formatted JavaDoc or API that's actually not intended to be API. Just briefly, back when I was working on the JDK itself, don't include negative examples in your code. Those are examples that say don't do this, because what we've got these days is a generation of Stack Overflow users who just find the first snippet of code and they copy and paste it, and then they'll file bug reports on you. So just a very brief example, I wrote this JavaDoc a long time ago and said, a warning about inserting nodes into the combo box under the list. This is strongly not recommended. Rather than the following code, you should do the following. The number of bug reports I got on that first snippet of code made me realize negative code samples are not a good practice to ever have. And never have a partial code sample either, because developers aren't going to discern whether it's a partial or a complete code sample. They're just going to find the first block of code and copy and paste it. Always just have a complete code sample. So our goal is to get everyone moving in the same direction. That's us as a team of library developers. And we should have a clear understanding of the language that we want to convey to the users, the functionality that we want to expose, and yeah, we don't want it to feel like it was developed by a bunch of different minds. We want it to feel like it was one collective that built it all. And like I said, it's not a science; it's an art. There is no magical process to API design, and it becomes easier with practice. I don't think in the last 23 odd minutes I've given you any real useful guidance, but it's just one of those things that you hone over time. So I just wanted to finish up very briefly with a few useful links. I've spoken a lot about what my team does, the Azure SDKs for Java. This is the GitHub repository at aka.ms/Java SDK. This is our GitHub repository where we are building the next generation of Azure SDKs. I highly recommend everyone to try them out. I would love to hear feedback from all of you, because we've put our hearts and soul into these libraries and they are state of the art. To help you make use of those libraries, I know Azure has a free tier. There's a bunch of credit, a lot of stuff for free for 12 months, and a lot of stuff that's free forever. So check out that free tier for Azure. Like I said at the beginning, this is a presentation that I've given a few times in the past. Normally I have an hour or more to present it. I talk about a whole bunch of practical guidance in those presentations, which I just couldn't cover in the 25 minutes today. I've got aka.ms/Java API design that just takes you to my website where there's longer form videos. And also in the same place, Microsoft sponsored a dzone ref card, which I wrote a few years ago, which boils down a whole bunch of my guidance in the form of a really nicely formatted dzone ref card. So with that, thanks. Like I said, I would love to hear from you. If you've got any feedback or questions or comments, jonathan.giles@microsoft.com or on Twitter @JonathanGiles. So thanks.
I've been speaking on mute, of course. Thank you so much, Jonathan, for the presentation. I've seen this actually. I've seen your talk perhaps too many times because you've been sharing this content so passionately over the years. And the ref card was a great asset that we put out there that really nails. Here are the top X things that you gotta focus on. And for anybody who wants to go deep, they can go to your full length talk and all the good stuff that you have. So definitely thank you for sharing in this condensed time frame the most important things.
It was an interesting challenge to boil down to 25 minutes. Some useful
Yeah, that's
guidance.
for sure.